Alright, hello. I'm back from my trip. I'm going to miss the hotel showers very badly. I spent like a total of 30 minutes showering in that one night. Anyways, alright, let's talk about the poor pigs. This is Leetcode, day 3 of my streak. Uh, I I had to watch a tutorial for the theory behind it, but I'll try to do the math myself. Yeah, speaking of math, is a very big math problem. It's about pigs and poisoning pigs with buckets of liquid. Um, this is actually very similar to a problem I faced in discrete math with like knights and poison wine glasses, but pretty much the solution to that was like with some binary stuff, and it's very creative, I think. But okay, so let's talk about these tests and T is the total amount of time you're allowed to test, and D is the amount it takes for the pig to die. So if you had one pig, you could test two buckets of poison, potentially poison buckets, and the question gives you the number of buckets, um, and you have to okay, yeah, okay, that's right, that sounds about right. And then you need to provide how many pigs you need. But pretty much you have um, time to test, time to die, and if you have one pig and 15 minutes to test, 15 minutes to die, you could test two buckets because you would feed one pig one at time zero, and if at 15 it dies, then this is the this is a bad bucket. Here, let me mark it. This is a bad bucket. But if he survives, then this is the bad bucket. I hope that makes sense. And for 30 here, we would do something very similar, test at 0. If they don't test at 15. And then if it survives, then it's the bad bucket. If it dies at 15, it's a bad bucket. If it dies at 50, dies at time 30, this is a bad bucket. Dies at time 15, then this is the bad bucket. Okay, and and we're gonna call this a state. The time to test over the time to die plus one because this is the number of buckets that you could test with one pig. Okay, and note the plus one, which is the untested bucket. And now we could experiment with the number of pigs. So we have two pigs right here, and here's what we have. We would feed bucket one to pig one at time zero, bucket two to pig two at zero, bucket three to pig one and pig two at zero, and then an untested bucket. And what this does is, if just pig one dies, then this is a bad one. If just pig two dies, this is a bad bucket. If pig one and pig two dies, then this is a wrong bucket. And if nothing dies, then this is a bad bucket. Okay, I hope that makes sense. And um, for three pigs is very similar. Instead, you would stack it. So this is like all the combinations, and then you would also have every pig drink one bucket, and then that gets you eight. It's a permutation problem, and the answer of how many buckets you could um, you test is the number of states, which is time the time over the other time, raised to the power of number of pigs. So, for example, two states, three pigs, that's 2 to 3, which is 8, as you can see right here. And with three states and two pigs, you have something like this. Um, yeah, and note that it's interesting here. Pig two gets this bucket at 15, while pig one gets at 0. And the rest of the coding solution should be pretty easy. It would just be you increment the number of well, you are given the states, so you do like simple division with that, and then it's just easy math. and I'm gonna start recording once I have the coded solution up. Okay, fast forward. The coding is done. Here it is. So you just do the division, right? And then, fortunately, this floors the double for us. And then we add 1 because of the untested bucket. And we start pigs at 1. Oh yeah, and there was an edge case with the buckets. If the buckets was equal to 1, then there's only 1 poison bucket. So we return 0 because we don't need any pigs. And here's the test. Yeah. Before I had 1 pigs equals 1,000. When if oh sorry no, if math.pal is if this is equal to buckets, but then that's no good because sometimes you need more. Um, so I did greater than or equal to, and then we return pigs, and then if not, then we increment by 1. This pretty much doesn't trigger, and there's a slight memory issue, which I think. Let's see. I guess I could do like. Actually, I don't know. I'll take a look and then start recording again. Okay. Surprisingly, this was the hardest part of the problem. But it was like about like the accuracy and like the rounding part. Um, to optimize it, you just pretty much use logarithms instead of a for loop to figure out the the number of pigs. And yeah, so a lot of I had to round. I had to search up how to round because I don't know how to round in Java. Python has it so easy. They just do this and it's done. Um, Thank you, AlphaCode, for showing me the way today. But yeah, and Java is a little more complicated. You have to first round this part, um, uh, and then divide it to get the to get rid of the unnecessary decimals, and then at the end you sealing it because you always want that one extra pig if you don't have enough. But yeah, pretty much that's pretty much it. Now it beats uh, in terms of memory, so that's good. And yeah, I learned a lot today, and it's great to apply some things I learned from discrete in here. So yeah, thank you. I'll keep on. I'll see you tomorrow.